Good morning, students. In this lecture, I am going to discuss a very important topic, which is image formation by spherical mirrors. In the last few lectures, we discussed what is meant by spherical mirrors and what are the laws to draw ray diagrams. Using those laws, by applying it in special cases, you can draw ray diagrams and you can find the image formation by such spherical mirrors. So by doing this lecture, my intention is to make a clear concept about image formation by spherical mirrors. Okay, so in order to do that, first thing we must do is to draw a spherical mirror. First we need a spherical mirror, then only we can draw ray diagrams. Okay, so while doing this area, you must take proper measurements. Okay, so I will tell you how to draw a spherical mirror. For that, for any mirror you need a radius of curvature. Okay, any mirror, if you consider, it will have a radius of curvature, so that you can set it. Is up to you, you can set it. So let us take some small radius of curvature, otherwise it will take so much of space. So I am taking 2 centimeter radius of curvature as 2 centimeter. Okay, that is the radius of curvature of my spherical mirror. It can be convex mirror or it can be concave mirror. So now next thing is, since you set the radius of curvature, now draw a circle with radius 2 centimeter, so that you can draw a circle which is having radius 2 centimeter. Okay, so I am drawing a circle, let it be 2 centimeter. Now its radius is 2 centimeter. So this is the center. From center it is 2 centimeter. Okay, so radius of curvature is denoted by r. So r is equal to 2 centimeter. Now you know that focus is always at the middle of radius of curvature. Radius of curvature is 2 centimeter, so focal length will be 1 centimeter. So focus will be at the middle. So you can mark focus. This is your radius of curvature r, and now this will be the focus. Okay, so this is r, this is f. Now let us imagine that you are using a concave mirror. You are using a concave mirror. So for concave mirror, the reflecting surface is this caved surface, isn't it? So the surface which is not reflecting, use shading. So I am shading this surface because this is not the reflecting surface. I need only this much portion, I don't need the rest of the portion. Okay, so that I can remove the rest of the portion. Now I am removing the rest of the portion. Now you can extend this line. So I am extending that line. This line you can extend. I am extending in this direction and in this direction. Okay, so you got your mirror. This is how you can construct your mirror. Here you can note down all those things. Your radius of curvature is 2 centimeter, so you can note it. This is the radius of curvature, its value is 2 centimeter. This is the focal length, its value f is equal to 1 centimeter, because f is equal to r by 2. Since r is equal to 2 centimeter, f will be equal to 1 centimeter. F is nothing but focal length, and capital F is the focus. So you can denote capital F here. This will be the focus, which is capital F. Capital F means focus. Small f means focal length. Focal length is that distance, whereas focus is the point. Okay, so you got the lens. Sorry, you got the mirror. This is how you can construct a concave mirror of radius of curvature 2 centimeter. If it is 3 centimeter, then your radius of curvature will be 3 centimeter. Okay, now your intention is to draw ray diagrams. Okay, after discussing concave mirror, I will discuss about convex mirror. So your intention is to draw ray diagrams. In order to draw ray diagrams, you need an object, and then using that object you will find the position of image. Okay, so normally we will represent objects by using arrow. This is object. So let us do one thing. Let us use a different color for object. I am using red color. Now this is my object. This size shows the size of the object. If this arrow is more in length, then that much length is there for the object. If it is less in length, then object is also small. So this size represents the size of the object. Okay, and this tip is the head of the object, and this is the tail of the object. Tail will be always on the principal axis. As you already know, this is the principal axis which we discussed already. Tail is always on the principal axis, and head is here. Okay, now you can see this is the radius of curvature. R is equal to 2 centimeter, and this point is nothing but center of curvature, because you already know it is a circle. The center of the circle is called center of curvature. So that point is center of curvature C. You already know. Now you can see what is the position of your object. What is the position of your object? I am using here position of object. What is the position? You can see it is C, it is F. So your object is beyond C, means after C. Okay, so we will use the word beyond C. Beyond C means it is after C. Your object is here, your C, center of curvature is here. So object is beyond C, it is after C. So we will denote it as beyond C. Now when your object is beyond C, you need to find where the image will form. Image means after reflection you can see your object through the mirror somewhere. That is called image. Okay, when you look in front of that plain mirror in your home, that is in front of almirah, you can see your image in that almirah. You are the object, and your image in that glass is the image. Okay, so let us find where the image will form in this case. In order to find that, you need to apply those rules. You already know 4 rules. So let us apply those rules. For applying those rules, the condition is that in order to get an image, you must remember this. In order to get an image, the condition is that at least 2 reflected rays, please remember this, at least 2 reflected rays must meet at a point. So please remember this. In order to get an image, at least 2 reflected rays, it must be reflected rays, they must meet at a point. then you will say that you will get the image at that point where these two rays are meeting. Okay, so the condition to get an image is at least, it can be more than two, but at least two reflected rays must meet at a point, then that point is said to be the image point. Please remember this point, at least two reflected rays, if they meet at a point, then we will say that we are getting the image at that point. That is how we can get image. Two reflected rays must meet at a point, then that point is called image point. Okay, so now let us apply that here. In order to do that, we need two reflected rays, minimum two we need, isn't it? So let us do one thing. First, let us consider a normal light ray which is passing through this. You already know a parallel light ray. After let us use another color. A parallel light ray what happens after reflection? Since it is moving, I will mark arrow here. What happens for this ray? After reflection, it will pass through focus, isn't it? A ray which is parallel to principal axis. You can see this light ray is parallel to principal axis. So after reflection, what is the rule? A ray which is parallel to principal axis, after reflection it will pass through the focus. That is the rule. So naturally it will pass through the focus after reflection. Since it is moving like this, you must put the arrow like this, isn't it? This is first rule. We applied the rule 1 here. So a ray which is moving parallel to the principal axis, after reflection it will pass through the focus. You got one reflected ray. This is one reflected ray. Now you need one more reflected ray and check where they are meeting. That meeting point will be the image point, isn't it? In order to do that, you can take any ray, that is up to you. You have 4 rules, so any rule you can apply. I already applied rule 1. Now I can apply rule 2, rule 3 or rule 4. Any rule I can apply so that I will get a ray. So I am applying a rule. You are having a rule that a ray which is passing through C, center of curvature, after reflection it will retrace the path. That means if a ray is passing through center of curvature, then after reflection it will come back in the same path. So I am drawing a ray, I am drawing a ray through C. What happens after reflection? Since it is moving, let us do one thing. Since it is moving, this is the moving ray. Now what happens after reflection? It will retrace the path, means it will come back in the same path. So it is coming back in the same path. Arrows will be on the same line, isn't it? Now you can see they are meeting. Two reflected rays. You can see one reflected ray. This is the first reflected ray, and this is the second reflected ray, because the ray which is going, it is coming back in the same path. So the reflected ray will be same as the incident ray. So this is one reflected ray, this is another reflected ray. Now you can see both the reflected rays, they are meeting, isn't it? You can see there is a point where they are touching each other. This is the first reflected ray, this is the second reflected ray, they are meeting here. So this is the image point. Okay, in order to represent that, we will mark it. This is the image point. Let us use another color. So you got the image, isn't it? You must mark it on the touching point itself. It is actually not clear in my diagram, because you need to take proper measurements, then only you will get it clearly. Okay, I am just explaining the process in a rough manner. If you take proper measurements, you will get clear image. Okay, so that point, if they are touching like this, I will just give you an example. One ray is moving like this through F. This is F. If this is F, and another one you can see through the lens, it is coming back. So this is the point they are meeting, and this is your principal axis. You can imagine. Oh, since you marked F here, now you can see this is your image point. That is what happened in the previous case. Okay, so this is the size of the image. You can compare object and image. So first let us write the position of image, where the image is formed. Position of object is beyond C, and what is the position of image? These are the things you must write in all the cases: position of object, position of image, size of object, size of image, then nature of image. So position of image is, where is the position? You can see it is between C and F. It is in between C and F, isn't it? So position is between C and F. When you place the object beyond C, then your image will be formed in between C and F. Now, what is the size of the image? If you compare image and object, you can see that object is having more size, image is having less size. So such images are called diminished images. When image size is less than object size, such images are called diminished images. So your image is diminished. Now another thing, you can see your object is like this, okay, whereas image is actually 180 degree rotated. It is called inverted. It is the original position, head is here, but here you can see it is rotated by 180 degree. Such an image is called inverted image. So your image formed is actually inverted. So another nature of image is, it is inverted. Okay, so position you got. Now these are the characteristics. First characteristic, it is diminished. Second one, it is inverted. Now third one, you can see your image is also formed on the same side, same reflecting side, isn't it? You are having a reflecting side and you are having a non-reflecting side here. Since your image is formed on the reflecting side itself, such an image is called a real image. An image formed on the reflecting side of the spherical mirror is called a real image. So here your image is formed in the reflecting side itself, on the left side itself. So it is a real image. So third property is, it is a real image. Okay, so these are the characteristics of the image formed in this case. Image is formed in between C and F. It is small in size, so it is called a diminished. It is 180 degree rotated, so it is called an inverted image, and it is formed on the reflecting side itself, so it is called a real image. Okay, so for all those diagrams, the procedure you need to apply is draw a spherical mirror with some radius of curvature. Take proper measurements using compass, then draw a circle, remove the rest of the portion, then as I already explained, mark principal axis, center of curvature, radius of curvature, focus, focal length, etc. in your diagram. Then place an object. Object can be have any size, but always take some 2-3 centimeter size object. Using an arrow, mark it. Then apply the rules of reflection. You are having 4 rules of reflection. You need minimum 2 reflected rays to get an image. So you need minimum 2 rays. So that apply any 2 rules. Any 2 rules you can apply. Then check the point where those reflected rays are meeting. That is the image point. Then find the position of image and characteristics of image, as I discussed already. In the same diagram itself, you can apply in some other rule also. Here you can see, instead of this passing through C, which is coming back through C, you can apply some other rule. Instead of that, if you want, you can apply a ray which is incident like this, which is called oblique incidence, which is rule 4, will get reflected obliquely. So it will pass like this. Again you will get the reflected ray. Any rule you can apply, but your image point will be same. Any rule you can apply, but all the characteristics and image formation will be same. It will not change. So it is up to you which rule you will apply. Any of the 2 out of 4 rules you can apply. This is how you can draw ray diagrams. So I explained the case of beyond C. Now next we need to place the object. So in this case, where we placed the object, we placed the object beyond C. Now where we got the image? In between C and F we got the image. Now in this one you can write the characteristics of image, or we say that nature. Nature means characteristics. What are the characteristics? It is diminished, then inverted, then real. So this is a box. Now second case, at C. At C means, instead of placing it beyond C, here. If you place your object at C, then check what happens. So roughly I will give you, if this is your mirror, this is just a rough diagram. If this is C, now place your object at C. Okay, and check where you will get image and what are the characteristics of image, and complete this table. Now between C and F, do the same thing. Then at F, do the same thing. Now finally between F and pole, do the same thing and fill these boxes. I am giving this as a work for you. All of you please do it, and I will tell you when to submit. Okay, so first go through this lecture, then do it yourself. Any doubts you can ask. You are free to ask any doubt. So in all these cases, please remember that take proper measurements. 2 centimeter if you are taking, it must be 2 centimeter. Any small error in measurements will be reflected in your diagram also. You will not get the accurate diagram. So take proper measurements and do the different cases. Do it today itself using compass and other measuring tools.